Okay, so hello everyone, welcome. Can you hear me? Hello.
Hello,
Yeah, can you hear me?
I can
Yes,
hear you.
yeah,
Yes.
Wait for joining other all of the other participants, then we'll start. Okay, so now we'll start our today's class. So basically today is our fifth number of class. And so mainly today we will try to discuss about the some topic for the air quality monitoring using the Google Earth Engine platform. How we can easily monitor the air quality parameters such as carbon monoxide, then suppose sulfur dioxide, nitrogen dioxide, or other types of gases, how we can easily monitor and also make the analysis in Google Earth Engine platform using that. Okay. Okay. So now we'll start for this air quality monitoring class. So let's go. So I simply share my screen. Okay. So now can you see my screen? Okay. Can you see my screen now?
yes.
Yes, it's loading.
Okay. Okay. So now I will. Okay. Okay. So let's go to discuss. Okay. Okay, so basically today is our fifth number of class, and so mainly today we'll try to discuss about the some topic for the air quality monitoring, how we can easily perform the air quality monitoring analysis using the Google Earth Engine platform. Okay, such as nitrogen dioxide, then sulfur dioxide, then carbon monoxide, or methane, okay, or other types of class, how we can easily monitor other types of air quality parameters. Okay, how to download the air quality data as a time series data in a CSV file format in Google Earth Engine platform, then how to convert this unit from mole to molecule, mole per meter square to molecules per centimeter cube, how to make time series chart of this air quality parameters, and how to export this map and use the ArcMap software for making the research paper map of presentation map. Okay, so first of all you can see these two type of map. So one map is that methane concentration map of Kuwait, another is the nitrogen dioxide concentration map for Bangladesh, year of 2020, month of January. So here we can find out the one unit is the PPB. This unit is the PPB. Another unit you can see, this another unit is that mole per meter square. Okay. So different types of unit we can easily get from here, and also convert different types of unit in Google Earth Engine platform for the different types of gases. Okay. And also you can see this is another is that nitrogen dioxide level rebound in Bangladesh for the different time period, such as pre-lockdown, during lockdown, post-lockdown. Okay, so basically all of those things, all types of map, we are get the data from the Google Earth Engine platform. Finally, this TPMS final make the process this map using the ArcMap software and create this type of layout. Okay, so let's go to this class. So basically, there's a lot of way for remote sensing using the air quality monitoring. In this time, we are just work for the Sentinel-5 satellite imagery. Okay, Sentinel-5 satellite imagery. So mainly this satellite imagery provide the information about the different types of composition or climate interaction with the main data products being ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane, or an atmospheric ozone, stratospheric ozone. Okay, with daily global coverage for climate, air quality, and ozone surface UV applications. Okay, so this type of gases we can easily access from the Sentinel-5 satellite imagery for the air quality parameters. Okay, and this is the dataset link. We can simply go to this link and get the Sentinel-5 satellite imagery, all of those dataset. Okay, so first of all, I simply open this dataset and try to show you that how it will be work. So I can simply copy this dataset link from here. Suppose I simply copy and then open in a browser in here. Okay, so now you can see here, this is a Sentinel-5 satellite imagery. So basically this Sentinel-5 is mainly collect the data useful for accessing the air quality parameters. And this is the tropomi instrument, is multispectral sensor that records the reflectance of the wavelength important for measuring the atmospheric concentration of ozone, methane, formaldehyde, aerosol, carbon monoxide, nitrogen dioxide, sulfur dioxide. All of those gases we can easily access from here. You can see carbon monoxide, formaldehyde, nitrogen dioxide, ozone, okay, and methane, sulfur dioxide, okay, and all of those data set we can get access as a global data set. Okay, so in this time you can see all of those for the all of those data set is the same process, but in this time I will show you suppose carbon monoxide, this data how you can easily handle. Using the same process you can also handle the other types of data such as formaldehyde, sulfur dioxide, carbon monoxide. This type of data we can easily handle. Okay, so let's go. I simply click on here. So now I can get all of this information about this data set. You can see this is the data set availability date. We can get the data set between this time period of 2018 to 2023 06 19. Okay, and data set provided is that European Union. Okay, ES Copernicus, and this is the Earth engine snippet. Okay, so basically this is the unique ID of this data set, and full data set is stored in this variable, in this link or in this snippet. Okay, so this is the unique ID. Okay, also you can see this data set has a different types of band such as carbon monoxide column number density. Also you can see water column number density. Also you can see cloud height, sensor altitude, okay, sensor azimuth angle. Okay, different types of band we can get in here. Okay, also you can see description about the data set, what's that formula or what's the algorithm they are using for create the data set, you can get from here. Okay, so in this time I want to use this data set and try to find out for the carbon monoxide for any region, then also make the time series chart about that. Okay, and also calculated other part about the work air quality monitoring. Okay, so first of all I need to import that. So for that what can I do? I simply copy that, simply copy, and then okay, also need to open a new code editor. Okay, and then simply paste here this image collection snippet ID and give a variable name. Suppose I put the variable name is that CO. Okay, you can use any name. Okay, so now what? Just I simply import my image collection in my code editor. Okay, so after that I need to just simply use a function, select function, and which band I want to work. In this time I want to work with this band, nitrogen number, column number, density. This band I want to work. So just I simply copy that, and you can see this unit is that mole per meter square. Okay, and this is the vertical integrated nitrogen column number density. Okay, so in this time I want to work with that, this band. So I simply copy this band from here and just select with this band. Okay, and then simply use a function about that for a specific time period. I want to use this data set, suppose filter date, and select the specific time period such as start date and end date. So put here suppose 2020 or 23, 2023, suppose January, and put here suppose 2023, suppose January 31. Okay, so I can the month of January, year of 2023. Okay, so now I want to simply check how many images are available for this. So simply use here the CO and use here the size function. So now we determine how many images are available for my between this time period. Okay, we can get the total 426 images are available. Okay, so now I want to use this 426 images, and if you want to check about the time period about this data set, okay, so we can get the image collection information. In this time we can get all of this image collection acquisition time period. You can see from the feature. So here you can see the all of those images only for the one band. Okay, and first image you can see the we can get the year of 2023, 1st January. We can see all of 1st January, 1st January. Okay, also you can see the another thing is also 1st January. Okay, so basically in this time this data set also gives you some 2nd January. Lot of times 2nd January can get in here. Okay, basically this type of result I can get the same date for the different time because this data set is also different on the time. Okay, suppose in suppose 1st January, 1st January which time access the carbon monoxide. Okay, so it also different also time. So suppose in this time it's showing the result, you can see a lot of time 1st January, 1st January, 1st January, 1st January, 1st January, but which time I access the data for my region. Okay, so this is the main. Suppose I can get a lot of time for the 1st January, but I can get the access the carbon monoxide suppose at 9:28 p.m. or 3 p.m. or 10 a.m. Okay, a specific time period. Okay, so which time period I can access the material or access the data for the air quality parameters. Okay, so that's why in this time you can see a lot of 1st January I want to get in here. Okay, but also you can see for the 2nd January, for a lot of 2nd January I also get in here. Also you can see this also 3rd January, 4th January. Okay, we can get the data 5th January, 6th January, lot of time. Okay, but from this time suppose 8th January I can get all of those things, but I can get only for the one time. Suppose 8th January 10 p.m. I access the carbon monoxide for this region. Okay, then it will be considered and calculate this result. Okay, so for that in this time when I want to visualize this image collection, so first time I need to reduce this image collection. Okay, so in this time I want to observe the result, all of those pixel value, all of those images I calculated the average pixel value. Okay, so for that what can I do? Same process, we need to use here the reducer. So take a variable, suppose I put the variable name is the average carbon monoxide. Okay, after that then simply call this variable name because it is stored total 426 images, and this 426 images I want to reduce. Okay, and then how I can reduce? I want to calculate the average carbon monoxide concentration. Okay, so put here the ee dot reducer dot mean. Okay, so in this time suppose you want to need for the maximum concentration of carbon monoxide, just put here the max. You want to need the minimum, then put here the mean. Okay, but in this time I want to display the result about that average pixel value of carbon monoxide. So that's why I simply use that, and then simply use here the map dot add layer function, and also call this variable name and paste here. Okay, so in this time when I run this code, we can check what happened. We can get the result about. So in this time I think we can get the result for the globally because we did not put any region. Okay, so in this time we can get the look like that. Okay, as a black color. So I want to show the result as a colorful map. So for that what can I do? I can simply copy their visualization code. You can see they're already create about the visualization code. Simply copy that from here and paste, and simply copy that and then paste after the object name. Now click to the run. So now this color will be added with my whole world nitrogen dioxide map, year of 2020, month of 23, month of January. It working? So mainly red color is identify the high density of the nitrogen dioxide, sorry, carbon monoxide, okay, for this high density region. Okay, for this region is high density. Also you can see this is the red color. Okay, then you can see black is the lowest. After the blue you can see, so this type of blue region you can also get in here. Then purple color, okay, then cyan, then green, then yellow, and highest is that red color. Okay, red color identify the highest density of nitrogen carbon monoxide. Okay, so in this time, suppose this result I need only for the specific boundary, such as need only for this Bangladesh boundary or India or any other region. What can I do? Just I simply from the asset, I simply import my shapefile of the Bangladesh. Simply import the Bangladesh shapefile, and then I just simply use the another function, clip function. Just clip with that. Suppose clip with table. Okay, this is my shapefile variable name table. Okay, now when I click to the run, in this time I can get this result only for this Bangladesh boundary. Okay, you can see. So now it display the result about that only for the Bangladesh country boundary. Nitrogen carbon monoxide density map year of 2023, month of January. Okay, so you can see full Bangladesh is the red color, so it means that it's showing the high density. We can get the some low density in here for this hilly tract region. Okay, otherwise all of this region we can get totally a red color. Okay, so it means that this is the carbon monoxide density is the high for this time in Bangladesh. Okay, so now you can get this result look like that. Okay, so now you can easily export this map, okay, as a tip format. Okay, after easily export this tip format and make this map look like that. You can see this map, suppose you can see this is nitrogen dioxide map. Just from this map we can simply use the ArcMap software and display the result for our research paper or our presentation work. Okay, just simply download these tip images. Okay, when you can download the tip images, we can get the unit as the mole per meter square.